Mr. Sol Coleman from Group 20.
Hello, this is Dakari Grant from Group 20.
Hello, this is Samuel Jones from Group 20.
In terms of file structure, inside of the root folder, there will be 3 subfolders. One demo, containing the link to the demo video, the design folder, which includes the design template, and the scripts, which will contain the 5 SQL scripts.
Our table names are all plural. Double words are joined up with an underscore. Our attributes follow the same naming convention. Double words are joined up with an underscore. There are no conjoined words. There are no derived words. Our data types are standardized throughout the unit, throughout the attributes. We've got singulars for decisions, singulars for yes, no's, varchars for names, numbers for IDs, varchars for slightly longer IDs, numbers for incrementing IDs, dates for dates of birth, and so on and so forth. Our constraints, we have our primary keys, foreign keys, compound primary keys, all connected to the attributes, and we have our unique constraints on their correct attributes as well. We also have our not nulls where they're necessary. We only have one default, and that is the default of Y. Hello, I'm Dakari Grant, and I'm going over the create SQL file. We have 11 tables, 12 mandatory foreign keys. We have one default Y on active status in the modules table. All our practice cases standardized. The naming, there are no derived names, and double names have joined in with an underscore. We have our comments, we have our run command, general, just comments, and test queries. I shall not run it. There we are, table created, no problems, no issues. Time to test the case. And there are all our tables in the database. One more test. And there are all our table names, 11.
Hello, this is Samuel Jones. I'm going to be running you through the constraint script for our database. So firstly, in our database, we have 11 primary keys, 3 of which are compound primary keys. We additionally have 13 foreign keys, 3 of which are also compound foreign keys. So looking at our script file here, for constraints, at the top we have run command, and primary keys. Starting up with primary keys, the commands we're using here is alter table with table name, add constraint, constraint name, primary key, and the attribute from the table. This is repeated for all 11 of the tables in our database. Next, we have the comment here for test queries. This will be ran to see if the constraint names are displayed properly in Oracle. Moving on, we have the forward keys. The forward keys have alter table, table name, add constraint, the constraint name, foreign key, the attribute, and the reference to the parent table. Moving on, we have unique constraints, 3 of them here. So we have alter table, add constraint, and unique. And lastly, we have check constraints, which is alter table again, add constraint, and check. This one in particular is defined by in, same with this one. The third one here is between, and the last one is upper. So looking at our script here, we have good use of practice names with table names and constraint names all being correct throughout the script, and there should be no errors in that regard. Additionally, we have the correct syntax with the use of semicolons, parentheses, underscores used correctly throughout the script as well. And lastly, the commands are all uppercase, displayed throughout the script again correctly. So next, we're going to run the constraint file here. Firstly, I'm going to log into Oracle, like so. And I've already ran the create script from before, so there are tables already in Oracle. Next, we're going to run constraints. As you can see, it all says table altered and no errors occurred. So next, what we're going to do is run this command here for the test queries to test if our constraint names are there. It might take a second. There we go. So as you can see, that is the constraint names for all 13 of the foreign keys, all 4 of the check constraints, all 11 of the primary key constraints, and the 3 unique constraints. That covers constraints script. Hello, this is Samuel Jones. I'll be running you through the insert script for our database here. So looking at our script file, we have the use of 3 insert statements per table. On top of that, identified here with the first use of our insert is the primary key, showing that we have entity integrity shown. Next, looking at examiners here, the primary key in examiner is also a foreign key in modules. So showing here in modules, we have the use of referential integrity as well. You may have noticed in our design that we have got long stretches here, meaning we're about column lists. Scrolling on down again back to table modules, we have made use of our defaults by setting the default values for all of our data types in our database. Something else to look at as well is the correct formats for our text, for our numbers, and the date of births. So text files here are shown in the correct format. Numbers, again, correct format. And date of birth, or dates, correct format as well. So something else with the design here is that we've used snake case. That meaning we don't have spaces or no spaces. We make use of underscores, and we also don't have any uppercases. So looking again at the top here, we've made use of some comments. So we've got run command, test queries, which we'll show later on in Oracle to show that you have the inserts inputted correctly. So over here in Oracle, I'm going to log on here, and I'm going to copy this command. So what I've already done is I've ran the create script and the constraint script, so that we have something in our database to be shown. Next, I'm going to run the insert script here. As you see, when it's run, there's been no errors. Next, what I'm going to do is copy this, put it in here, and we're going to type in examiners, for example. And as you can see in examiners, the inserts for examiners are inputted correctly. Thanks for listening.
This is the queries.sql file. On line 6, we have a query to select all from one table. Line 9, we have an example of a projection query selecting multiple columns. On line 15 to 17, we have an example of a restriction. We are restricting our search to specific rows, in this case where surname is like starting with C. After this, we have a logical comparative operator greater than or equal to. We are comparing date of birth. We have an example on lines 25 to 27 of a joining query where we are joining data from two tables. We have examples of complex queries. For example, we have restriction and projection, as well as logical comparative operators happening in one query here, for example. Entity and referential integrity are maintained throughout. For example, primary keys are related before foreign keys, for example here. In reference to entity integrity, all selections are made with the primary key shown to ensure that we know that each row that we are getting is unique. This is the results from the queries. As you can see, we have everything from that table here. I'm going to use the submissions as my example. That's the second to last query. It had two conditions. One, that the submission date is between the 1st of January and the 16th of March of 2025. As you can see, that is the case here. The second is that the marker ID is not equal to 10132981. This is the case for one of the two options. See drop.sql. Firstly, we have the drops for referential constraints, the foreign keys, and then the primary keys. Afterwards, we have the drops for entity constraints. We drop all unique constraints. After that, we have the drop for domain validation constraints, all of the check constraints. And finally, the dropping of tables. All tables are dropped. At the end, we then are ensured that we purge. We have comments to say exactly what constraints are being dropped and where. And at the top, we have our run command. For